Firstly, the grounding electrode conductor, or GIC, that is a number 4, bare wire could create an electrical shock hazard if it comes into contact with any live wires. Secondly, the 10/2 with ground non-metallic sheath cable is connected to a circuit that might not have ground fault circuit interrupter, or GFCI, protection. The National Electrical Code, or NEC, requires ground fault circuit interrupter protection for outlets in areas with a potential for moisture, for example bathrooms, kitchens, and garages. The insulating foam compatibility with electrical cables is a concern, as not all insulation foams are compatible. Incompatible foams may release gases that could damage or corrode cable insulation. If the type of insulating foam used in the draft-stopped hull is not compatible with the cables, it could be a fire hazard or damage the cables. The number 4 grounding electrode conductor is larger than necessary for the 10/2 with ground non-metallic sheath cable. The maximum grounding electrode conductor size for a 10/2 non-metallic sheath cable is number 6. Using a larger grounding electrode conductor than necessary might create a potential for ground loops and could interfere with proper grounding. The C85E cable is not an electrical cable and does not require grounding. It should not be bundled with the electrical cables. Recommended actions include installing a ground fault circuit interrupter outlet for the circuit that feeds the 10/2 with ground non-metallic sheath cable. Replace the bare number 4 grounding electrode conductor with a number 6 grounding electrode conductor. Make sure that the insulating foam used in the draft-stopped hull is compatible with the electrical cables, and separate the C85E cable from the electrical cables. Ensuring ground fault circuit interrupter protection is crucial in areas prone to moisture. Ground fault circuit interrupters work by monitoring the current flowing into and out of a circuit. If there is a difference of as little as 5 mA, the ground fault circuit interrupter trips, cutting off the power and preventing electrical shock. Common locations requiring ground fault circuit interrupter protection include bathrooms, kitchens, garages, outdoor receptacles, and any other area where water might be present. Always consult local codes for specific requirements. Checking insulation foam compatibility is vital for preventing damage to electrical cables. Certain types of insulation foam contain chemicals that react negatively with cable insulation, leading to corrosion, cracking, and eventual failure. When selecting insulation foam for use around electrical wiring, make sure it is specifically labeled as safe for use with electrical cables. If there is any doubt, contact the foam manufacturer for verification. Using the correct cable size is essential for safe and effective electrical grounding. The grounding electrode conductor connects the electrical system to the earth, providing a path for fault current to flow in the event of a short circuit. The size of the grounding electrode conductor must be appropriate for the size of the service entrance conductors. Using an oversized grounding electrode conductor can create ground loops, which can cause unwanted current flow and interfere with the proper operation of sensitive electronic equipment. The National Electrical Code Table 250.66 provides guidance on selecting the correct size of grounding electrode conductor. Separating communication cables like C85E from electrical cables is important to prevent interference and maintain signal integrity. Electrical cables can generate electromagnetic interference, or EMI, which can disrupt the signals carried by communication cables. To minimize interference, keep communication cables at least 12 inches away from electrical cables, or use shielded communication cables. The National Electrical Code provides guidelines for the separation of power and communication cables in Section 725.136 and 800.133. When installing electrical wiring in wood-framed buildings, it is important to follow proper techniques for drilling holes through studs. Holes should be drilled in the center of the stud, and they should be no larger than necessary to accommodate the cables. When multiple cables pass through the same hole, they should be neatly bundled together and secured with cable ties. The National Electrical Code Section 300.4 specifies requirements for protecting cables from physical damage. Draft stopping is a fire safety measure that involves sealing openings in walls and floors to prevent the spread of fire and smoke. When draft stopping around electrical wiring, It is important to use materials that are fire resistant and compatible with electrical cables. Avoid using flammable materials such as paper or cardboard, and make sure that any foam insulation used is specifically designed for use around electrical wiring. The National Electrical Code Section 300.21 addresses the requirements for maintaining the fire resistance of walls, floors, and ceilings. When working with electrical wiring, always follow safe work practices. Turn off the power to the circuit before working on any electrical components. Use properly insulated tools and wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The National Electrical Code Article 110 covers the general requirements for electrical safety. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. All electrical equipment should be properly grounded in accordance with the National Electrical Code. Grounding electrode conductors, or GECs, connect the electrical system to the earth, providing a low impedance path for fault current to flow. The size and type of grounding electrode conductor must be appropriate for the size of the electrical system. The National Electrical Code Table 250.66 provides guidance on selecting the correct size of grounding electrode conductor. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground. Bonding helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The National Electrical Code Article 250 covers the requirements for grounding and bonding. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electrical shock. Ground fault circuit interrupters monitor the current flowing into and out of a circuit, and if there is a difference of as little as 5 mA, the ground fault circuit interrupter trips, cutting off the power. Ground fault circuit interrupters are required in areas where there is a risk of moisture, such as bathrooms, kitchens, and outdoor receptacles. The National Electrical Code Section 210.8 specifies the locations where ground fault circuit interrupter protection is required. Arc fault circuit interrupters, or FCIs, are devices that protect against electrical fires. Arc fault circuit interrupters detect arcing faults, which are a common cause of electrical fires, and cut off the power to the circuit. Arc fault circuit interrupters are required in many areas of the home, including bedrooms, living rooms, and dining rooms. The National Electrical Code Section 210.12 specifies the locations where arc fault circuit interrupter protection is required. Surge protectors protect electronic equipment from voltage spikes. Voltage spikes can damage or destroy sensitive electronic equipment such as computers, televisions, and appliances. Surge protectors divert excess voltage away from the equipment, protecting it from damage. The National Electrical Code Article 280 covers the requirements for surge protection. Electrical boxes are used to enclose electrical connections and protect them from damage. Electrical boxes must be properly sized and installed in accordance with the National Electrical Code. The National Electrical Code Article 314 covers the requirements for electrical boxes. Conduit is a type of tubing used to protect electrical wiring. Conduit can be made of metal or plastic, and it is available in a variety of sizes and types. The National Electrical Code Article 342, 344, 352, and 356 cover the requirements for conduit. Cables are used to carry electrical current from one point to another. Cables are available in a variety of sizes and types, and they must be properly sized and installed in accordance with the National Electrical Code. The National Electrical Code Articles 310 and 334 cover the requirements for cables. Wiring methods refer to the way in which electrical wiring is installed. Common wiring methods include non-metallic sheathed cable, or NM cable, metal-clad cable, or MC cable, and conduit. The National Electrical Code Chapters 3 cover the requirements for wiring methods. Overcurrent protection devices such as circuit breakers and fuses protect electrical circuits from overloads and short circuits. Overcurrent protection devices must be properly sized and installed in accordance with the National Electrical Code. The National Electrical Code Article 240 covers the requirements for overcurrent protection. Electrical panels are used to distribute electrical power throughout a building. The electrical panels must be properly sized and installed in accordance with the National Electrical Code. The National Electrical Code Article 408 covers the requirements for electrical panels. Transformers are used to change voltage levels. Transformers are used in a variety of applications, such as stepping down voltage for residential use or stepping up voltage for industrial use. The National Electrical Code Article 450 covers the requirements for transformers. Generators are used to provide backup power in the event of a power outage. Generators must be properly sized and installed in accordance with the National Electrical Code. The National Electrical Code Article 700, 701, and 702 cover the requirements for generators. Renewable energy systems, such as solar and wind power, are becoming increasingly popular. Renewable energy systems must be properly designed and installed in accordance with the National Electrical Code. The National Electrical Code Article 690 and 694 cover the requirements for renewable energy systems. When working with electrical wiring, it is important to follow all applicable codes and regulations. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The National Electrical Code is updated every 3 years, and it is important to stay up to date on the latest requirement. Local codes may also apply, and it is important to check with your local building department to determine the specific requirements in your area. Always prioritize safety when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock and fire. Regularly inspect electrical wiring and equipment for signs of damage or wear. Replace any damaged or worn wiring or equipment immediately. Keep electrical panels and equipment clean and free of obstructions. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat and potentially start a fire. Use extension cords sparingly, and never use extension cords as a permanent wiring solution. If you need more outlets, install additional circuits. Be careful when working around water. Water is a good conductor of electricity, and it can increase the risk of electrical shock. Never touch electrical equipment with wet hands or feet. Do not use electrical appliances near water, such as in the bathroom or kitchen. Teach children about electrical safety. Children should be taught not to play with electrical outlets or cords. They should also be taught what to do in the event of an electrical emergency. If you have any questions about electrical safety, contact a qualified electrician. An electrician can provide you with advice and guidance on how to keep your home and family safe from electrical hazards. Remember that electrical work requires precision and adherence to safety standards. If any doubt exists, consulting with a licensed electrician is always the best course of action.